Okay, naming the transformations. So our original equation is just a y equals x squared. That's just a basic y equals x squared. So what does this all do to that? Okay, so we have a negative multiplier. So the negative multiplier makes it flip. Then the 2 as a multiplier will make it more narrow. And this saying a subtract 1 inside the brackets will actually make it move right 1. And then after, when there's a plus 6, that's going to go in which direction? Up. I'm guessing you forgot all those, so if you do on the test, here's what I'm going to do. A y equals x squared, and then I'm going to also graph that. On a normal zoom 6, if I graph them, okay, well, I can see it's upside down. I can see that. I can see that the vertex is not here anymore. The vertex is over there. So where did the vertex move? Right 1, up 6. I can see it. And this would be up to your discretion. Can you see that it is a little bit more narrow than that one? Okay, so that's what we first learned. Okay, given the next equation on number 2, we're going to do all those things. So let's plot it in here. So y equals get your equation in. And then my graph is just a zoom 6, just to see. Okay, when you draw your rough sketch, can you make sure your x-intercepts, y-intercepts, and vertex are kind of where they seem on your graph? So obviously my x-intercepts are both negative, so I showed you that they're both negative on my graph, right? Okay, everyone's good with how theirs looks? Direction of opening, it opens up. I can obviously see from the graph, but algebraically, it's because there's a 2, a positive 2 in the front. That's why. The vertex, can you get me that, which is a minimum? So you can go to your calculator, find it. So you know that you don't have to always scroll down here in this menu. You can actually just hit the number 3 and it will go. Left and right. So -3, -7. And I knew that algebraically because this is left 3, down 7. Okay, what's the equation for the axis of symmetry? So That is, what's the equation of this cutting line right here? If I cut it through the middle, it's always an x equals, and what x value does it cut through? What is this x value? Same x value here, which is -3. Okay, x-intercepts. So now I'm going to find these 2 points, which in the menu, those are called a 0. So I'm going to calculate 0. Can you work and get both of them? So you know how to do that. Second, calculate the 0, and then left and right bound them. How are we doing? -4.87 and -1.13? Okay, the y-intercept. So here's the point I'm looking for on my graph. That's the y-intercept. So what do I do to get that? It's not in the menu. Do you remember which button you would push to get that? What's the x number right on that line? You're going to go trace 0, enter. Trace, get your mouse to move to 0, enter. So that's the idea there. You're saying, hey, go to the x value of 0. Because you can tell your mouse to go to any x value you want. You can't tell it to go to a y value, but you can tell it to go to x values. Okay, the domain, that's talking about how left and right, how much left does this graph go, how much right does it go. So the left is -infinity and the right is +infinity. So left to right. The range, so what's the low to high? So what's the lowest height? So we're here. This is the lowest height, which was -7. And then when we go up the graph, it keeps going, 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 going. Okay, name a point symmetric to -1, 1. So that would be there. So I would want to know the point that's like the flip-flop of that. Okay, so do we remember this line was a -3, and this point is at a -1. So how much is that point away from the split line? It's 2 away. So let's go 2 in that direction. Where do we get to on an x value if we go 2 in that direction? We should get to -5. And then obviously the height is the same. Okay, so that was algebra-y, and I'm going to show you that you can just go into your calculator as well. Okay, so in my calculator, I could just do a y2. So I could do this at a height of 1. And then I could just say, well, where does this intersect again at 1? So calculate the intersection. When you do intersections, your mouse just needs to for sure be closer to that intersection than the other one. Okay, so you can see how I can also do that. So I don't care how you do it, I'm just showing you 2 different ways to kind of go about it. Okay, what is the height of this graph when x equals 2? So this is what I'm going to do. I'm going to go trace 2, enter. That's all I do. When I have an x value, I can tell my mouse to go there. So I hit trace. Okay, what positive x value is the height of 100? So on this one, I'm going to need to do, this is a y value. I can't tell my mouse to go to y values. I can only tell my mouse to go to x values. So I'm going to do a y2 of 100. But guess what I'm going to have to change? I'm going to have to do stuff to my window. Okay, so if obviously my y2 is 100, should we do a y max of 1, I don't know, what do you want to do? 125? Up by 10s? Because I have to be able to for sure see a height of 100. So graph. And this said a positive x value. So I want that x value. I don't want this one because that's a negative. So what is the x value at this intersection? Okay, so can you calculate the intersection there? Okay, so when you have an x, you can just straight enter it. When you have a y, you got to do the intersection. Okay, where does this equal this? Okay, so what I'm going to do, obviously I could go algebra. If I was a pre-calcer, I'd be doing all this maneuvering and solving. Applied, we're just going to say, where does this equal this?
What page is this on?
Is this not on the next page?
No, when I click the page, I go to question 6.
Did I miss a whole page? There's no questions 3?
Yeah, I think the entire page is gone.
Okay. I will photocopy that again. Not sure. Okay, so where does this equation equal that equation? So I'm going to let my calculator do the work. So where does this equation equal that one? So I'm going to go into my y1. I just accidentally didn't photocopy that one page. Okay. So I'm going to graph this. Why don't we reset our graph because we had our 100 and some in there before. So zoom 6 is the thing that will reset your grid. So I zoomed 6 when I was done. Okay, so this is what I need. I think I need to see a little bit higher, probably a little bit lower, and maybe a little bit more left. Okay, so window. I'm going to go negative 15x. I'm going to go negative 20y and positive 20 on the y. And then I'm going to graph and see. You never know. You might have to try it a few times. That's all fine. Okay, that's pretty good. I mean, I don't see the top, but I need to really think about the intersections. So it says, give me a quick sketch. So that's kind of what my calculator is showing me. So how do I answer this question? I need to get the intersection. And I need both. So you're going to have to do both. So can you work to get those numbers? And really what I'm actually wanting to solve this, my last thing when I'm solving an equation like this is going to be x equals. That's how I'm stating my answer, x equals. And I can see that there's going to end up being 2 x values that will work. So can you find those x values that will work? Okay, I got 2 answers and you're maybe wondering, well, how does she do that so quickly? I'm going to show you maybe just a calculator trick here. So let's pretend that I'm on this one. I've already gotten my negative 8.855, etc., that one. The next time I know I'm going to be way over there and I don't want to think about moving my mouse after, So what I'm going to just do right now is I'm going to tell my mouse to go to like 2. And now you see how my mouse is over there? It's closer to that one. So now when I go to the intersection, my mouse is just already over there now. Okay, I don't have to work to do all that scrolling the mouse because that seems to take a long time. So do you see that trick? I can tell my mouse to go to different spots just by pushing a number, enter. Okay, then I don't have to do scroll this, scroll that. As long as I'm understanding, oh, okay, that's over here an X value of close to this. Okay, number 4 is your factoring, and you're going to have your 4 types. So number 4A, this one is a simple trinomial. So give me 2 brackets, x times x So on the simple trinomial, you're trying to say what multiplies to 30. And then it would also have to add somehow to get you 11, so negative 11. So can you get 2 multiples of 30 that will do that? 5 times 6, negative 5 times the negative 6. So that multiplies to 30, adds to negative 11. So you have x equals 5 and x equals 6. Okay, I could always punch it into my calculator and find out that that's what it's doing. Okay, B. This style is a difference of squares. So 2 brackets. Okay, we have to say what multiplies to 9x squared. So something times something, and I want it to be the same thing. So did you pick 3x times 3x would multiply 9x squared? And what multiplies to 25? Plus minus 5. So the answer for the first bracket, so this one is where you're going to have to do opposite divide. So negative 5 over 3. And then this one is positive 5 over 3. Okay, C is a GCF. Greatest common factor. So I'm going to say, what can I take out of each term? Each term is divisible by, I could take out a 5 and an x. Okay, if I divided this by 5x, it would leave me with x. If I divided this by 5x, it would leave me with a subtract 4. If you feel like you don't know if you did it right, then remember you can always think, if I multiply it like that, does it go back to the original? Okay, here x equals, do we know that bracket? What would I have to do in the x position there? 0? Because 5 times 0, that's how I get a 0. And here x equals 4. Okay. We're going to factor this, so this is a complex trinomial. Okay, so when I start this, I'm going to go FLA, first times last. So first and last make 12. I could go with what multiples of 12? 1 times 12, 2 times 6, or 3 times 4. And I need it to make a plus 8 when I add those two numbers together. So which set? So those two numbers are going to multiply to plus 12 and add to plus 8. Okay, now I'm going to do, what are my options for the first? So I could go 1x times 4x. That's a way I could have done it. Or I could do 2x times 2x. How do I get the last? I can only do 1 times 3. Okay, what am I going to match with what? I need to make a group pair to make a 2 and a group pair to make a 6. So a 2 pair and a 6 pair. Okay, so I'm going to set this up with 2 brackets now. And the first is a 2x times a 2x. So I write the first and first in there. Okay, now I'm going to do outside partners, inside partners, because that's the FOIL, the out and the in. So I put the 2x with the 1, and this 2x with a 3. Do you see my outsides make 2x, my insides make 6x? Now I got my 8x. We already did all the sign work, so we said positives. So here x equals opposite divide, opposite divide. Okay, so verify by graphing, so we'll plug this in. Okay, so 4x squared plus 8x plus 3. I'm going to zoom 6 it when I'm done. Okay, I'm going to calculate the 0. Left, right. I got a -1/2, so that's good. -0.5. Okay, I'm going to second calculate a 0. Left and right. Don't have much room to move in there, but a -1.5, so that's good. Okay, do we understand -3 divided by 2 is -1.5? Okay, let's do these quadratic formulas, and then I think I would kind of say I'm going to stop, because that will be kind of a halfway point, I think. Okay, quadratic formula. So I'm going to write it out here. (b plus minus the square root b squared minus 4ac all over 2a. So don't memorize it. I will always give you that on a formula sheet. Okay, when we look at it, do we know what our A is, our B is, our C is? So here, A is 3, because that's how many x squareds you have. B is -8. That's how many x's you have. And C is -7. How many numbers you have. It doesn't mean what's first, second, or third. I could mix it up, so you have to pay attention. Okay, negative B, I'm going to write +8. Because I'm doing opposite, because it says negative B, so I do just the opposite of what I see. Square root. So thinking about this value squared, I'm not going to even touch my calculator. I'm just going to think, well, just what's 8 squared? 64. Because -8 squared is positive. So I often get this, people typing it in this way, which is wrong. If you really wanted to type it in, this is the correct way. Okay? So that's why it turns out wrong when people try to type it in. Positive, always positive. Subtract 4, bracket 3, bracket -7. All over 2, bracket 3. Okay, now I'm going to go to my calculator. I'm going to get, what is this? 64, subtract 4 times 3 times -7. That's what I'm typing in. And I get 148. Does that work? Okay, so I'm going to show you, you don't need to write this down, what it looks like in your calculator when we type it. Okay. Because our calculator does some extra brackets, I think. Ready? 8 plus the square root of 148. We're going to have to do 2 brackets there because your calculator does a bracket on the square root. So you're going to have to go 2 brackets to close the square root and to close the top. Okay, are we good with how to type that? Double bracket on that, divide by 6. 3.36. Okay, now I could retype it, but I have a trick for you. Do you remember the trick? If you hit second enter, it brings the whole thing back. So second enter brings it back. Then you can just move left and change that plus sign to subtract, enter. So I didn't have to retype it all. I kind of shortcut it. Okay, and again, at this point, it says verify by graphing. We know how to graph it, calculate the zeros. You can check if those are right. Okay, so let's do one more of those. Okay, so everyone likes that. Did everybody find the second entry thing that came up? Okay, so here A is -1. B is +2 and C is -5. Okay, so I'm going to plug those numbers in. So x equals -2. plus or minus the square root of, okay, I'm not doing this in my calculator, but what is b squared? What's 2 squared? 4. Subtract 4, bracket the a value, bracket the c value. Okay, I'm going to go into my calculator and type just this piece, 4. Subtract 4 times -1 times -5. So just the square rooty part. So 4 subtract 4 times -1 times -5. Are we getting -16? Okay, I know something in math right now. There's just something weird happening with this question. Does anybody know what that is? What's going on in math with that? What's going to happen to me when I try to square root a negative number? You're going to get an error in your calculator. So when I answer this question for x, there's going to be no solution because my calculator is saying there is an error. So do you remember what this could look like? What is the visual? So let's graph this in our calculator. Looking at this, where are the x-intercepts? There are none. There's never going to be any. So do you understand this parabola? Right? It's here and going down, so it's, right? It never hits this line. It never will hit that line, ever. So that's why that came out like that.